Okay, here I've got question 3 from the Pythagoras quiz. It says, given the complex shape below, determine the distance of line segment BC. That's marked with the question mark right here. And it says, round your final answer to the nearest tenth. Now there's a couple of things I have to realize about this question. First of all, I actually have two right-angled triangles back to back. And I know that this one is a right-angled triangle as well, because anytime two angles form a straight line like this, the sum of those angles is 180 degrees. So that means if that one's 90, the other one is 180 minus 90, which of course gives me 90 as well. So I know that I've got a right-angled triangle here as well. Now it's obvious to me that I've got to start over here. I'm going to call this triangle 1, I'm going to call this one triangle 2. It's obvious to me that I have to start in triangle 1 because I have two side lengths on this one and only one over on triangle 2 here. So I'm going to have to figure out the length of this shared side by calculating in triangle 1 and transfer it over and use it in triangle 2 to get my final answer here. So the first step, and I'll redraw triangle 1 just to make it a little bit more clear. The first step is to figure out the length of this side right here. Now the first thing I should do is label that triangle. Across from my 90-degree angle it gets side length C. And sides A and B are completely interchangeable, so I'll call this one A and this one B. As long as C is in the right place, A and B can go on either side. So now I know I'm looking for side A, and of my three formulas, I'm going to choose the one that has A all by itself, and that would be this one right here. So in the formula, A squared equals C squared minus B squared, I can start filling in some values. C is 13 minus B, which is 5. I have to square them both, don't forget. And then follow my order of operations. So 13 squared gives me 169 minus 5 squared. 5 squared is 25. And now I have to subtract 25 from 169. Leaves me with 144. Now that doesn't make any sense as an answer. That side can't be 144 if this one's 5 and that one's 13. Doesn't make any sense. So that reminds me that I have to take the square root of both sides. On this side to isolate A, and on this side to match what I did over here. So the square root of 144 is 12. Now that measurement goes right here because it was this side of triangle 1. I can replace that with 12 now. And it's also the shared side in triangle 2. So when I redraw triangle 2 to solve for my final answer, I can put a 12 here, because I just found that, a 35 here, because that was given in the question. And what I'm looking for is the hypotenuse, or side C, of this triangle 2 over here. Sides A and B can get labeled anywhere, so I'll put an A there and a B there. And I'm looking for side C. That means I choose the first of these Pythagoras formulas. So I'll write out C squared equals A squared plus B squared. C squared equals 35 squared plus 12 squared. C squared then is 35 squared, 1,225, plus 12 squared, 144. Add those up. 144 plus 1,225 is 1,369. And of course I've got to take the square root to get C by itself, and I'll do the same on the other side of equals because that has to stay balanced. So I can leave that number on the calculator, just hit square root, and I've got an answer for C of 37 units. And that's the final answer to this question. They asked it to be rounded to the nearest tenth, but since there's no decimal, it just stays the way it is.